What's happening, dogs? Mr. Allen here with some exponential amounts of fun here. We got exponent simplification here. We got to simplify each one of these. Final answers need to contain only positive exponents. It's pretty standard boilerplate instructions when simplifying exponential expressions. So first one here, I've got 3 times x to the 4th times y times 4 times x squared times y to the 8th. Woo! All right, all multiplication here, all multiplication. Now, a common error here, okay, when getting into exponents, as we know, with like bases, we add our exponents. With like bases, we add our exponents. 3 and 4 are still just numbers. It's multiplication. 3 times 4 is 12. Okay, we're not doing 3 plus 4 and getting 7 here. All right, normal math applies. All right, so x to the 4th times x to the 2nd, since we're multiplying with like bases, we're going to add our exponents. 4 plus 2 is 6. I get x raised to the 6th power. Then we have y times y to the 8th. Secret exponent, right? It's y to the 1st. So 1 plus 8 is y to the 9th. Final answer for that one. Dope. Excellent. Awesome. Changing colors. We're going green. All right. Here, I got a little bit more going on inside, and I got an exponent outside here. So it's kind of like this problem, but with a little more to it. So we're going to build on all these things. So let's see here. We got 2 times 4. So I'm going to set up my parentheses here, 8. And then I've got x to the negative 4th, x to the 1st here. All right, that's going to be x to the negative 3rd. And then I have y to the 3rd, y to the 1st. That's y to the 4th, all raised to the 3rd power. Now, you could have chosen to put this x to the negative 3rd down to your denominator and create a fraction. I'm going to save that for the end here, all right? So now I'm going to distribute the 3. So I'm going to get this 3 goes to the 8 there. Now, does that mean it's 8 times 3 to get 24? No. It's 8 to the 1st power. That exponent gets applied to that. So I'm going to have 8 raised to the 3rd power. I'm not sure what that is. That's 64 times 8. Some stuff. I'm not going to do that. All right. And then we got x to the negative 3rd to the 3rd. That's x to the negative 9th. And then I've got y to the 12th. All right. So now for our final answer, because we can contain only positive exponents, I'm going to need to move this x to the negative 9th to the denominator. So I'm going to create a fraction. We got 8 to the 3rd power. Then I have y to the 12th over x to the 9th. If it's non-calculator, they probably wouldn't make you do 8 to the 3rd. All right. You could probably do it. Let's see if we can do it. Let's see here. 8 times 8 is 64. Okay. So 64 times 8. Now, I'm thinking 60 times 8 is what? 480. So 480 plus 4 times 8 is 32. So is that 512? I think that sounds right. Yeah, that sounds right. Okay, so we could throw 512 up there if we wanted to. So we get a 512 y to the 12th over x to the 9th. Even better final answer there. But there we go, man. That's pretty dope. That's awesome. Fantastic. All right. Lovely. Next one here. Sorry, I was a little distracted by some sirens. I think they got Santa going around town right now. And they got the little parade happening. That's exciting stuff, man. Or maybe it's because the Bears just won, beat the Lions. I don't know, man. Either way, it's happening. Okay. Go Bears, 5-8. All right. So here, I've got myself a little fraction going on. I got a negative exponent. Here's what I like to do, okay? You guys can probably hear that now, can't you? I like to clean up my inside first, okay? So I'm going to do that. So I'm going to have 2 over 6. That is definitely Santa Claus going by. We got 1 over 3. Jenny's howling out there right now, too. We got 1 over 3. This 2 over 6 simplifies to 1/3. Then I have x to the 1st over x to the 4th is, let's see here. I'm going to take my larger exponent of 4, subtract 1. That's 3. Wherever my larger exponent was, is where that goes. Jenny is howling it up right now. She loves howling at sirens. So I hope you guys can hear it. Otherwise, I'm just laughing for no reason right now. All right. Next one, we got 6 and 2. So y to the 6th over y to the 2nd. 6 minus 2 is 4. So I get y to the 4th right here. And this is still raised to the negative 2nd. So now that I've cleaned it up, right, and dealt with what I can in the parentheses there, I got to deal with this negative 2. Personally, I'm going to flip this thing, make it a positive 2, okay? So if I flip the inside here, I'd have 3x to the third over, I'm just going to write y to the fourth. I don't need that 1 anymore. All that is squared. And now I can distribute that exponent of 2. So we got 3 to the second, right? Or you can think of it as 3 to the first. So 2 times 1 is 2, right? And then we get 3 squared is 9. So we get 9. X to the third squared. Multiply those exponents. I get x to the sixth over. And then we're going to have y to the 4 times 2 is 8. Nice. Excellent. Hopefully we could see that and didn't come off the screen. I think we got it. Excellent. Cool. Last one here. So I've got 2 individual fractions here that I got to deal with. This negative exponent's kind of a pest, right? So I think I want to do some things here first. So this guy here, we're going to write it. We can actually distribute our exponent in. So I'm going to have 4 to the first power squared, or just think of it as 4 squared, right? We're going to get 16. Then I got x cubed squared. Well, those exponent properties, power to a power, tells me to multiply. We get x to the sixth, and then we get y squared. Okay, nice. And again, I like to write this to the first power because a lot of people think, oh, it's 4 times 2. No, it's not. We're not just multiplying the numbers, any numbers we see. When it's a coefficient there, right, we got to treat it as 4 squared. And if you can't quite justify that because you're in the realm of exponents, I find it helpful to throw a 1 up there, which would mean I'd have 2 times 1, so it would be 4 squared, and then I get 16. Now for this next part here, for this next trick, I'm going to take this mess right here, I'm going to throw it in my denominator. The inside stuff stays, but now this becomes cubed to the positive third. I've taken this whole mess, moved it to my denominator, it changes the outside exponent to a positive 3. Pretty dope. All right, next up, for my next trick, I got 16x to the sixth y squared over. Now I can distribute my exponent. It's always, people struggle when there's just a negative here. Perhaps writing it as -1. Sorry, that kind of melted into the x there. But -1 is what's really there. What's -1 to the third power? -1 times -1 is +1 times -1 is -1. So I'm going to have -1 here. And then we got x squared to the third. That's x to the sixth. And then y to the eighth to the third. 8 times 3 is 24. Now I can simplify. It looks like my x to the sixth gone. And then I got 24 is the larger one. So I'll do 24 minus 2 is 22. Final answer is going to be my negative. I'll throw that up in the numerator, -16 over y to the 22nd. That one was quite a bit going on, especially honestly in these two right here were probably the more challenging ones in my opinion. Negative exponents, flipping it. That's a good move there, but I always like to clean up on the inside first. Same thing goes here. Like, see how I cleaned up on the inside here first? Oops. And then I applied the exponent of 3. I always clean up on the inside of my parentheses before I start dealing with any exponents that are outside. That's just how I do it. There are a couple ways of starting these things and going through these things, which makes it confusing. So finding a common process can be very helpful. All right. Hope you guys liked that and enjoyed it. Hope you found it to be exponentially fun as much as I did. Got to add one more joke in there, okay? And otherwise, have a great day, dogs. See you later.